Thanks. I have almost the same topic as Martin about cloud automation. Therefore, he mentioned a lot about, or a lot I would have mentioned, but that doesn't matter in the end. I think I have enough topics to cover. He haven't mentioned. Short about me, I work as a database consultant at Edorex, a small company in Bern in the middle of Switzerland. I'm a member of the ACE program and I'm currently at home. Therefore, ACEs at home is quite a good name. You can reach to me via blog or Twitter. I'm also one of the organizers of the Oracle Beer Bern meetup in Bern. If you visit Switzerland and you have the chance to visit the meetup, we always have beer and great discussions. Feel free to join. Martin mentioned a lot about the failures you are able to do in the cloud or chances you have to open all your data to the public. Therefore, the cloud has tools which are really powerful, extremely powerful, and can destroy your whole IT or even more. It depends on what data you lose. Therefore, it's quite important to know what you're doing and to take care that you're not exposing all your data or anything else to public or to not to the right person. And I think Martin mentioned it too, and I really think that these are the important points. Start early with designing and take care that you're not changing further on is quite heavily. Or in other words, or the words of Stan Lee, with great power comes great responsibility. And we, as most of the people I've seen in the chat are DBAs, we are not used to network or firewalls or so on. On normal on-premises infrastructure sites, we do have network admins, we do have security admins and so on who help us designing all the stuff. And I think in the cloud it's too easy to lose everything. The tools and options we do have in the cloud are quite good. We have a hell lot of possibilities to automate anything and to automate all these processes. We can start, stop infrastructure, we can provide infrastructure, we can deploy SaaS solutions, we can create backups, we can restore everything automated. I think everything you can imagine can be automated by tools like Martin mentioned before or showed before, Terraform, or in this case, in my presentation, Ansible. The goal should be that we have bright sky, not the thunderclouds. We have a lot of tools, and to automate, the question before was what are the alternatives to Terraform? The Oracle Cloud itself provides some ways to automate. There are ones, the APIs, REST APIs for all OCI objects with REST endpoints for creating almost everything. Then you have the SDKs, you have the Java SDK, you have the Python SDK, you have Ruby SDK, you have a Go SDK, and you have the CLI SDK for the command line interface, and Terraform. And in this case, we have Ansible. Terraform, now everything is an expert. I tried to show you what Ansible is. Martin mentioned it already. In contrast to Terraform, is Ansible agentless and lets you work with Unix, Linux, and Windows configuration targets, and it's built modular. You're able to provide your own modules, or you can use the modules from the Ansible Galaxy store, or you can use modules from a third-party provider. In this case, I use the Ansible modules from the third-party provider Oracle. Oracle develops the Ansible modules. And one good thing of the ACE program, you get some good tips. Then today I updated all the infrastructure and for my test environment, and Oracle changed from Ansible modules to collections. For everyone who is using already Ansible with Ansible, I think 2.10, Ansible changed the way of using modules. They are now collections, and Oracle used this point for defining the Ansible modules as legacy and create new Ansible collections. That's for the development. It wouldn't be a huge problem if they just move to a new GitHub repository, but they also changed all the module names. I think the new module names are much better than the old ones, but I had to really change my demonstration. Yeah, in the chat is mentioned that 2.10 is the first version of collections. The collections of Oracle are since September, I think, in out of beta phase. Therefore, you probably should use the collections module or collections repository, but you have to be on 2.10 then. If you use Ansible, we write playbooks. In these playbooks, we can use these modules or collections, and we have an inventory, and then we have managed hosts. If you're already using Ansible for automating your whole infrastructure, then probably there is the biggest difference to the normal Ansible way, because you don't have a real inventory for the Oracle Cloud. You define the hosts as local host and connect then to the Oracle Cloud. Normally, you'll define an inventory with all your hosts, and on these hosts, you're executing your scripts. As shown before, Ansible, we have the Ansible OCI module or collection, and these module or collections are using the OCI Python SDK. Therefore, it's important to have also the Python SDK installed and configured. Ansible itself is written in Python. Therefore, it's easy to use for Oracle to use the Python SDK. But take care, there are dependencies between the modules and the Python SDK version, because the different versions of the modules or collections of Oracle OCI are using different OCI Python SDKs. Therefore, you have to take care that you are up to date. And probably you have to adopt sometimes your code then. The installation is quite easy. You enable, in this case, I have an Oracle Linux 7 system, and you enable the developer EPL, install Git, install Ansible, the Python pip, and Python pip stands for package installer for Python, then the OCI. You clone the OCI Ansible modules. I have to update this slide I've seen to the collections Git repository, but I'll do it in advance to sending it out to the ACES at home administrators. That's almost everything. Then we have to change to the directory and install Python, install.py. That's everything. An easy way or a nice way for using this is if we use virtual environments. Virtual environments provides us the possibility to have a different environment for different cases. Then we have all the dependencies for this Ansible module in this virtual environment, especially if we use Ansible Tower or anything similar. It's probably a good way to use a virtual environment. Then we do not have any impact from all the other stuff. Probably someone is using Azure and is having their different versions and so on. With a virtual environment, we encapsulate all our installation. The installation is almost the same. We install pip virtualenv and virtualenv wrapper. We create a virtual environment. In this case, I name it OCI Ansible. Source this environment, install OCI and Ansible in this Python environment. Install the modules again, and we are ready to use the OCI Ansible modules or collections. Then we are also able to use the normal installation from the Galaxy repository, but with the modules, the Galaxy, I had some troubles, or I was not a real friend of the Ansible Galaxy, but that's probably mostly a personal part. With collection, it's quite easy, I think, and then next slide I will show with the collection. We install the developer repository. We install OCI Ansible collection. We install the OCI Python OCI SDK. And from Ansible Galaxy, we install the collection Oracle OCI. That's it. As mentioned before, we have to configure the whole story. The Ansible modules or collections are based on the OCI Python SDK. Therefore, the installation is exactly the same as if we would use the Python or the command line interface is running the same way. We create our directory.oci. We generate our private and public key. Sorry, and extract the public key. Now we have to copy the public key with the fingerprint to the Oracle Cloud that we are able to use this private public key constructs. Then we need a config file in this .oci config folder. We define our user OCID. You'll find this in the Oracle Cloud, I think, on the bottom of every page with your fingerprint, with your key file. Then we define which tenancy and region. We are able to provide a default or many different configurations, as many as we like to. But the default is probably the easiest one. As soon as we have everything set up and ready to go, we can test the module. An Ansible playbook, I call it like this, or I describe it like this. Probably it's from a developer perspective not the correctest way, but I'll call it header in this case. As mentioned before, we define hosts, local host. If we would execute the playbooks on different hosts, on premises, or directly on a host with the host name or IP, we can define here directly the host or use an inventory with everything we want to. Then we are able to define some variables. In this example, we define a compartment OCID. Then we have the tasks. Every task should have a name. This name will be printed in the output of the execution. Then we use the module. As it's exactly the same as with Terraform. These are Oracle specific. You're not able to execute these on Azure or somewhere else. Therefore, if you write your OCI Ansible playbooks, you're able to execute them on the OCI, on the Oracle Cloud. In this case, the OCI Autonomous Database Facts module will list all OCI autonomous databases in this compartment. Registering is a way of saving output of a task. The output of this task is registered into the facts variable, and I'm able to print the facts variable here with this writing debug message and then the 2 brackets facts brackets. With compartments, it's almost the same, but as mentioned before, they renamed everything. But I really like the new naming because in this case, it's OCI database, autonomous database facts. For instances, it would be OCI compute instance facts and so on. It's probably a little bit easier to find something. I have an example in the presentation before we go for a real demo. I have this example is also on my blog. Restart all always free databases in your environment, in your tenancy, because when Oracle started the always free databases, you had the problem that you have to restart. You had the problem. I think the bug is now solved, but you had the problem to restart all your always free databases around every 90 days. First of all, I have to gather all compartments because we can have Oracle always free databases in many departments. We save this list of compartments in the variable compartment list, but we need the IDs out of this compartment list. I use the set fact task and use JSON query for extracting these compartment IDs. There are different ways of doing it. I only use this way to show you're able to really dig into JSON with the possibilities Ansible is providing. Then we get a full list of compartments. That's the output of compartment list, but we really only want these IDs. We need also the regions, because in each compartment we can have always free databases in probably Frankfurt and in Zurich. Therefore, we need also the region list. That's also with this module OCI region subscription facts. We get all the regions, all the information of the regions. We register this output to the function to the variable region sub, and gather all the information, or use the JSON query for gathering the regions. That's the output we get from the region facts. And finally, we are able to loop over the regions and the compartments and find all our always free databases. We got this information with the module OCI Autonomous Database Facts is free tier, true. We register this information into this variable. The Autonomous OCI Database Facts module provides a lot of information. Which version is available, which which connection strings, Apex URL, and so on. But we are only interested in the ID of this of the always free database we have in this. This is still the output. With all the information, now we have the always free IDs. We are able to restart the databases. I have excluded the task from this playbook because then I'm easier to able to loop. I loop over all the always free databases and use the restart function and stop the always free database if this always free database is started, and then again I start it again. That's an example on what you are able to do with Ansible. As Martin probably mentioned, Ansible is probably more flexible in working with already existing configurations. Terraform is probably better in defining if you have 4 VMs and you need now 8. You just change a parameter to 8 and then run and you have 8. That's harder to create with Ansible, but if you would like to work with individual components, probably it's in this case with all the always free databases and so on, it's probably easier with Ansible. I mentioned during the break the OKIT. OKIT stands for OCI Design Toolkit. That was a question if there is a possibility to design and extract Terraform or Ansible. OKIT is an open source tool provided by the A team of Oracle. It's a web-based OCI design toolkit. Currently, it's available in version 0.13.0. They're quite fast, or there are a lot of new versions. 0.13 was released on the 28th of October. 12 was on 7th of October. 11 was on 16th of September. It's around every 2 to 3 weeks a new version. It's still version 0.13. There are a lot of bugs. I'll go a little bit deeper into it at the demo, but it's a drag and drop based way of creating the architecture for the Oracle Cloud. It's not only a way for creating the architecture, you're also able to export your infrastructure to Ansible, to Resource Manager, to Terraform, and export it as a picture. And one easy way, or one great way, I think, is you are also able to validate the configuration. I'll go through to the screenshots because I like to show it directly. It is installed on Docker. Therefore, you're able, if you have Docker installed somewhere, you're able to install it with 2 commands and have it up and running. In this example, I have it on a demo VM, and we have here a blank canvas with 1 compartment. On the left, we have our tools. As mentioned before, we are still on version 0 dot something, and the tools we have are currently limited. For the analytic guys, there is still no analytics cloud available, but probably we could create a virtual cloud network. We could then define our subnet, a second subnet probably. We could have in the second subnet two compute nodes and probably a load balancer. That's quite easy. We probably need, as Martin mentioned, the security group, security list, of course, second security list, and some routing gateways, probably a network, internet gateway. So probably we have our infrastructure. We would like to have an autonomous database too. That's an easy way to create our infrastructure. We now have the possibility to configure everything. As an example, if you go to the network here, we are able to define this network. We have on the right side we have properties, validate, and cost estimation. I'm not sure how good the cost estimator is working, but you have one. I didn't do a really deep analysis on how good the cost analyzer is working, but you could use it as an estimate. The validate is quite good. You now know what you need to define, and you have the properties. In this property, we could define all the required parameters for this network. We now define the security list here. And for this one, we can define the second security list. For this one, we define the security group. Probably we'll define the backend instances for the load balancer and also the security group. Oh, well, let's define a second security group for this one. As you can see, it's quite easy to define everything. And if you start with Ansible or Terraform, it's probably a good way of starting, because if we go here for validate, we have now the warnings. Okay, we should probably define a public key for the instances. Probably also should define egress and ingress rules, and probably we should define a routing table. Could help. That's the routing table. Let's have two. Drop down the routing table 1 and the routing table 2. It's quite easy. Now we have everything set up, only the warnings, but we can start up the instance without the public key. Probably we will have some troubles with accessing all this. The nice tool, or the really nice thing here, is we are able to export it to a JPEG probably. And I have my JPEG of my Oracle Cloud architecture. Or for Martin's case, we can export it to a Terraform zip file. And we have these 3 files for Terraform. In my case, I've tested Ansible, and we have a zip file with the main and the variables file. The problem here is this Ansible playbook will not work directly. You have to adapt it. It's written currently for the modules and not collections, but you're able to use it. Another really nice way is Johnny asked for, is there a way for exporting the current installation? Yes, you can use the query. If you have set up everything correctly, you can use the query. I take my demo compartment and all the subqueries. Now the OCI toolkit connects to the Oracle Cloud in Frankfurt and gathers everything. I currently have here in the Oracle Cloud 2 compartments, a preview compartment and ACES at home compartment. With in the preview, I have a VCN and so on with an Oracle Autonomous Database. And I would be able to extract it or export this one to an Ansible playbook. If I open this main in the Visual Studio Code editor, not only Martin is using it, I'm using it too if I have to work with Windows. Normally I work on Linux. There, of course, I'm only using VI. Even Visual Studio Code is available on Linux too. But as you can see, you have the playbook and you have all the methods used for creating what I've designed or what I've shown in what currently is available on my compartment. It's also a huge list, and it's not working. You need some time to invest. This is the one which is working. I had to adapt all the OCI add facts to OCI identity availability domain facts, OCI region subscription facts to OCI identity region subscription facts. That's the collection name. And the adapted one, if I run the playbook I've created and simply starting, gathering some facts, get all the information from my availability domain, get my region subscriptions, create some facts out of it, get details of all the services, creates them to facts. Now it's starting with creating a virtual cloud network. Let's see if we already see something. Yes, the virtual cloud network demo ACES at home is running with routing table, security list, security group. Now, default security list is created, or if it's already existing, that's Ansible. If you execute something and it's green, nothing has changed. If it's yellow, anything has changed. Something has changed. And if it's red, it's failed, of course. That's exactly this playbook, which is executed. As seen before, getting the list for all the regions, getting everything in detail. Now I get the list images. As you can see, it's quite a long playbook. And if you start writing all your code or your Ansible or Terraform playbook, and you have to define every network step and everything by yourself, it's probably easier starting with the OKIT tool. And I need the image ID for an Oracle Linux instance, and therefore I had to get the images, and now it's starting creating one instance. Let's take a look. Now you can see I have two private. I have a private subnet and a public subnet, and in the virtual cloud network we have an internet gateway. We have NOT gateway and the service gateway. I think while this is running, I have some time for questions. I'll provide the link for the collections. That's the Git repository with the Git repository with the Ansible collections. I'll also provide the link to the documentation. It's quite hard to find the module index. And as mentioned before, the new modules or the collections are named according the part they're in. OCI Compute App Catalog List, OCI Compute Image, OCI Compute Instance, OCI Compute Management Cluster, OCI Database, Autonomous Database, OCI Database Backup, and so on. It's probably a long name, but I like the way they have built the naming. Now creating an autonomous database. Yes, I think I'll leave it running. Are there any other question now? Or Johnny, is this what you were searching for?
I mean, I was not really searching for it because I'm not going to do it right now, neither tomorrow. I was just asking a preventive laziness question, like I'm not going to write that thing, but I wanted it to copy what I already set up by hand once. So
as mentioned before, I'm even lazier than Martin.
I can still fight both of you in laziness. That's not a big deal. But I see what you can do with this tool, the one that you have on screen now, that you can import the existing configuration you have. But you say that it still doesn't cover some pieces like analytics and so on, if I'm not wrong. So this one is maybe a bit behind in, I will say, in functionalities compared to what Martin posted, like the blog post of the person I have no chance to pronounce the name, because they clearly show me that I can do 3 clicks on the cloud interface and I get the Terraform scripts for everything I need.
What I've tested. I could execute or export the the configuration to the resource manager. That's working. That's way better than the Ansible export.
Yeah, so that one seems to be more like 2 clicks done. So from a laziness point of view, I will take that one because it's just 2 clicks done.
I've not tested the Terraform export, and I can't judge how good the Terraform export is. The Ansible export, it's a really good starting point if we take a look at the code, especially if you would like to create your networks and all these things. You get the parameter you have to set. They are marked as required and marked as optional. Therefore, as a starting point, if you start with creating Ansible playbooks or Terraform plays, I don't know the name, if it's playbooks or whatever, it's quite easy to start. It's probably better than digging into the documentation. Would like the documentation for autonomous.
I mean, I must admit that at least on my side, I never used Terraform at all. So I saw it around. I saw that Martin was blogging about it, and now I saw his presentation. I did some Ansible playbooks to set up environments, but not to create them, just to configure them, install the applications I needed to configure them and to deploy my code. So I still see Ansible more like my hardware in a way. So my instances already exist. I just need to connect and do something on it. And that's why I struggle to imagine Ansible to create the environment themselves physically.
That's the big difference, because you have your inventory normally for Ansible. Here you just have localhost and
absolutely, and that's why I will say
connectivity.
this sounds wrong, at least in my view of how Ansible fit into my flow of my workflow. I will say in the past, I use it to configure an existing environment, to just install the application I need, to deploy the code I need, and to do all the click, 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 done kind of setup. I don't imagine it as, oh, I use Ansible as well to create the environments as instances and networks and so on.
What you can do is use your already existing playbooks for setting up Ansible or your VMs, your instances, after you have set up the infrastructure. It's quite easy to set up the infrastructure, and then you have the IP addresses and so on. Or if you use infrastructure as a service, probably like this one, this ACES at home instance, you are able to provide cloud init YAML files. These cloud init YAML files are descriptions on which packages should be installed after the setup and so on. You're able to fully configure the whole VM after the deployment. That would be probably the easiest way then. And I think Terraform is using almost the same for deploying instances, compute instances with an operating system and applications on it. I think you're using the cloud init YAML too.
I mean, Martin dropped off just a few seconds ago, so we will not have his point of view on the topic. But
then it's like this. No, I think it's really the cloud init. My Ansible playbook finished, changed 17. Let's take a look what I've created. I've created almost the same as Martin. I have a load balancer with two compute nodes and one autonomous database and some gateways in, I think, 5 to 6 minutes. Therefore, any further question? I think we are on time.
I don't see any other question, and yes, so the time is totally fine, not a problem at all. So at least it works. You can see it on the screen.
And Christian, the weather where I live is bad too.
Hey, great.
So if anyone has some question, it's now or never. Or actually, you can set up an Ansible playbook to send question to Julian later on.
Probably there are easier ways.
Yeah.
Could use the Twitter hash. Twitter handle is probably easier.
Yeah, even a scheduled tweet is easier. Come on. Just because technology doesn't exist doesn't always mean you have to use it. I mean, you can, but yeah, no.
So yeah, I guess thank you very much, Julian, for the nice presentation.
Thanks for having me.
It was nice to actually have it after Terraform because it's really like one face-to-face kind of setup. So thank you very much.